Let's take a look at the Tektronix TMT4. Let's do a quick scan using the TMT4 to scan and see the signal quality tests of a M.2 SSD drive. So what it's doing right now is we're doing a negotiation and training between the two devices, and we're going to see where these devices train. So it's a by 4 device, and we can see lane 0, lane 1. Lane 0 decided to pick a preset of 9. Lane 1 decided to pick a preset of 6. Lane 2 picked a 9. And lane 3 picked a 6. So different times these train, I see different combinations of 9s and 6s. So, but they're all pretty even. And you can see the CTLEs and gains and DFEs applied in order to get those eyes. But we've just done a complete test where trained on a by 4 device. So that was really fast to give us an idea that this device is working really well. Lane 1 doesn't quite have the amplitude inside the eye, but it's plenty open relative to everything else. So this is where trained. So now let's find out, is the training location the best idea and the optimized location? So if we go back into setup and do a custom scan, now you can see that we can go in here to the custom scan and say, what if, for sake of time, I'm actually going to just test one of the lanes, but I could test all the lanes and all the combinations and do that in a very fast manner. But we're going to test to find out if that P6 and that P9, if those help out. So what it's going to do here is when I run that scan, it's going to go and through the protocol layer inside, we are going to send the device under test and tell it to put out those different presets on those lanes and then equalize it and tell you what the signal quality looks like. So rather than letting them train, we are now forcing that device to go out and output different transmitter presets so that we can see what those presets look like when they're pushed across that compliance channel and received by the TMT4. So we can do the what if testing to find out, were the P6 and P9 the right optimal choices for when those two devices decided to train and negotiate when we did the quick scan. So what we can see here is we're going to start to see the different presets pop up, and we can click on this and see more detail. So P4, which doesn't have a lot of transmitter equalization, not real great. P5 has more amplitude. P6, maybe slightly better than P5. P7. So you can see how fast we're doing this test. And, you know, the estimate on the previous screen wasn't nearly as accurate as how fast this test ran. So we're done testing those 6 presets. So in the matter of just over a minute, we just tested a bunch of those, and we could see that for this link, I really wouldn't want to use P7 and I really wouldn't want to use P4. So P4 and P7 are the 2 worst signal fidelities. So the fact that they trained to P9 and P6, P6 is way up here and P9 is right there with it. So P6 and P9s are good choices for that transmitter to set to push across this compliance channel to our receiver. And if you want to know more about what's going on in the receivers, you also, not only did we draw those eye diagrams, but we have all the information to say what was the CTLE used and how much gain needed to be applied and what were the DFE values for working with that. So you can test and say, okay, here's how Tech's receiver trained with this transmitter. Does your receiver train the same way? So there's a quick video to show you how to use the custom scan to test your transmitter further to make sure that the training is doing the optimal setup.